In this lesson, we'll be going over basic chemistry nomenclature. By the end of this video, you'll be able to find the chemical name of any formula, as well as every chemical formula for every chemical name for ionic and molecular compounds, including ones with multivalent ions, as well as polyatomic ions. To start, let's look at the basics of ionic compounds. So of course, we know that it is a metal and a nonmetal attracted together as they are ions of opposite charges. Metals give up electrons and so they become cations. Nonmetals gain electrons, which is why they are called anions. In any ionic compound, we name it with the metal first, followed by the nonmetal. However, we change the suffix or the end of the word to "ide." So for example, if we had a compound with sodium and sulfur, it would be sodium sulfide, taking out sulfur's original ending and replacing it with this to make it a compound name. And finally, the most important thing, the charge must always be balanced, meaning that there has to be the correct number of cations and anions to balance the charge of the compound. Again, taking sodium sulfide for example, let's take a look at how we would write the chemical formula. Let's write down their symbols, Na and S, as well as their charges. Sodium has a positive charge, and sulfur has a -2 charge. To balance the charge, let's use the zero-sum rule. Pretty self-explanatory. It is a rule that we use to make sure that the charge is balanced at 0. So let's say we add the two charges together, 1 plus -2. This would equal to be -1, meaning that this is not balanced. How can we make it balanced? Well, we can multiply this 1 by 2, making it so that there's a +2 and a -2, so it can equate to 0. How does this relate to sodium and sulfur? Well, this tells us that we need to put 2 sodiums to balance the charge of 1 sulfur. So writing it out, it would be Na2S for sodium sulfide. A better way to figure out how many atoms of each element are needed in a compound, a more efficient way, is just doing a crisscross of the charges. So this sodium has a charge of +1. Not caring about the sign, let's put a 1 beneath the sulfur. Moving to the sulfur's charge of -2, we can cross its charge over to the sodium, which is 2. And as you can see, crossing the charges was able to tell us how many atoms of each element that we need. 2 sodiums and 1 sulfur. We have confirmed this by using the zero-sum rule. But we were able to solve it a lot quicker. Let's try another example with barium nitride. Let's write barium and nitrogen. Barium has a +2 charge, nitrogen has a -3 charge. Let's move over the charges for each element. Barium has its 2 move to the nitrogen, and nitrogen's 3 moves over to the barium, showing that we need 3 barium atoms and 2 nitrogen atoms to make Ba3N2. Let's confirm using the zero-sum rule to see if this is balanced. We have 3 bariums, which each have a +2 charge, plus 2 nitrogens, which each have a -3 charge. 3 times 2 is 6, plus 2 times -3 is -6. Adding them together gives us 0, showing that we have done this correctly. And we can move on to the next question. Magnesium oxide. Drawing out the atoms, magnesium and oxygen. Magnesium has a +2 charge, oxygen has a -2 charge. Crisscrossing the charges, there are 2 magnesiums and 2 oxygens. Now, does this mean that the chemical formula for magnesium oxide is Mg2O2? Well, writing it like this is actually incorrect. You see, when we are writing chemical formulas for ionic compounds, we want to make sure that the ratio of atoms is at its furthest reduced point. Seeing as the ratio to sodium to sulfur in sodium sulfide is 2 to 1, the ratio between barium and nitrogen in barium nitride is 3 to 2, the ratio in magnesium oxide can be reduced at 2 to 2, while sodium sulfide and barium nitride are already at their furthest reduced point. So pretty easy, we can reduce the magnesium to oxygen ratio from 2 to 2 to 1 to 1, making the formula for magnesium oxide MgO. And of course, whenever there is only one atom of an element, we refrain from putting a 1 and instead just put the chemical symbol. Obviously, if there are more, we would put a subscript with the number showing how many atoms are present in the compound. Now, going the other way, from the formula to the name, it doesn't matter how many of each atom there are, as the compound name is just what elements are included, with two catches. One, we just have to change the ending to "ide," and we have to keep the whole name in lowercase. So Li3P, this is obviously lithium and phosphorus, so the compound name would be lithium phosphide, replacing the ending and keeping the chemical name in all lowercase. We also have Ra3B2, this is radium and boron, and so the chemical name would be radium boride. Moving on, what about the multivalent ions? These can include, but are not limited to, copper, lead, and iron. Copper has a positive 2 and a positive 1 charge. Lead has a positive 2 and a positive 4 charge, and iron has a positive 3 and a positive 2 charge. That being said, there are a few different rules for ionic compounds with these multivalent metals. Let's use copper for a few examples. If we were to have a compound with copper with its positive 1 charge in a compound with oxygen, the compound would be copper 1 oxide, with the capital Roman numeral representing which charge of the copper is present in the compound. In terms of writing the chemical formula, it's pretty similar to the crisscross method that we've been using. So copper and oxygen, with copper's positive 1 charge and oxygen's negative 2 charge, we see that we need 2 coppers and 1 oxygen, so the chemical formula would be Cu2O. What if we use the copper 2 ion? Then of course we would need to put copper 2 oxide with the capital Roman numerals. And for writing the chemical formula for copper 2 oxide, we'll change the charge of the copper to positive 2, and so when we do the crossing of the charges, we will see that we need 2 coppers and 2 oxygens. However, this ratio can be reduced from a 2-to-2 ratio to a 1-to-1 ratio, making the chemical formula CuO for copper 2 oxide. Let's try to go from the chemical formula to the chemical name, and let's use PbO. So just from seeing this, we don't know which charge that this lead has. It could either be a positive 2 charge or a positive 4 charge. The way that we can figure out is we can do a reverse crisscross, showing lead and oxygen. There are 1 of each. Let's reverse these to find the charges. Now as you can see, the charges are positive 1 for lead and negative 1 for oxygen. However, any chemistry student would know that oxygen does not have a negative 1 charge but a negative 2 charge, meaning that this ratio has been reduced from 2-to-2 to 1-to-1. And so the charge of the lead is positive 2. And so writing it out, it would be lead 2 oxide. Now very quickly, let's go over ionic compounds between a metal and a polyatomic ion. You see, polyatomic ions are ions made up of several atoms. So for example, let's make a few compounds with sulfite, SO3 with a negative 2 charge. Let's make compounds with sodium, barium, and aluminum. Swapping the charges for sodium and sulfite, it shows that we need 2 sodiums and only 1 sulfite. So the compound would be Na2SO3 for the formula, and the name is obviously sodium sulfite. The ending is already done for us. What about barium and sulfite? Well, if we crisscross the charges, it shows that they both have 2, but we can reduce this to a 1-to-1 ratio, and so the chemical formula will be BaSO3, barium sulfite. And finally, if we have aluminum and sulfite, crisscrossing the changes, it shows that we need to have 2 aluminums and 3 sulfites. Now, this looks a little bit tricky. How would we write 3 sulfites? Would we take the number of each individual element in the ion and multiply it by 3 to make it S3O9? No, that's a little bit too complicated. Instead, let's start off by drawing out the two aluminums, so Al2, and then since the sulfite is its own entity, we'll put it in brackets with the subscript 3, showing that there are 3 of these sulfite polyatomic ions, and this is aluminum sulfite. So that's how you write out formulas and chemical names of ionic compounds. Let's move on to molecular compounds. Now, what do we know about writing out molecular compounds? Well, first of all, they're only made up of nonmetals. And in these compounds, there are not cations and anions, which have opposite charges attracting each other, but rather they are bonded together. Another rule is that there is no reducing for molecular compounds. So before in ionic compounds, the ratio of atoms had to be at its furthest reduced ratio, but in molecular compounds, we do not reduce the ratio of the number of atoms. Of course, we still add the "ide" at the end. These are called suffixes, but there are also some prefixes that we can add to the element's name. Let's take a look at what the prefixes for the numbers 1 to 10 represent. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octo, 9 is nona, and 10 is deca. How do these prefixes relate to molecular compounds? Well, let's take a look at the example down here. It looks like this compound is made up of 2 nitrogens and 3 oxygens. Using these prefixes that are assigned to the number of atoms present, we can name this compound. Obviously, we know that there is nitrogen and oxygen, so the name would be something close to nitrogen oxide. And simply just plugging in the prefixes for the corresponding number, di for 2 and tri for 3, we know that this compound is dinitrogen trioxide. What about CCl4? Well, we see that there is 1 carbon and 4 chlorines. So a good chemistry student would write out monocarbon tetrachloride following all the rules, except we only use mono if there is 1 of the second element. If there's 1 of the first element, we do not put the mono. If there were 2 carbons, then it would be dicarbon tetrachloride, but since there's only 1, it is carbon tetrachloride. And what about the other way from the name to the chemical formula? Phosphorus pentafluoride. We know that since there's no prefix for the phosphorus, it's just 1p. And pentafluoride, let's look at the legend. Penta is 5, so that means that there are 5 fluorine atoms to make PF5 for phosphorus pentafluoride. Using what you learned, try and solve these practice questions, turning chemical formulas into chemical names and chemical names into chemical formulas. The challenge of this, it is not stated which compounds are ionic, molecular, or multivalent ions. Always make sure that you're taking a look at what elements are present in the compound. For example, if there are only nonmetals and you don't see a polyatomic ion, then it's a molecular compound. If it's made up of a metal and a nonmetal, then it's ionic. And also you should look out for any multivalent ions, like copper, lead, and iron, like we discussed before. The answers to all these questions will be posted at the end of the video. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.